Hello guys, how are you? Welcome to Cosmic Essence Education. My name is Maitray, and in this video we'll be looking at the graphs of all the trigonometric functions. So let's get started. So let's start with the graph of y is equal to sine x. Now before going to the graphing of this function, let's look at the period of the function. Now what is the period of the function? First understand that. The period of a function is a value after which the value of the function repeats itself. Okay, the formal definition of a period of the function is f of x plus t is equal to f of x for all x. That means after t, the value of the function, that if I increase the value of x by t, the value of the function remains as it is for all values of x, then t is known as the period of the function. Okay, so for sine x, let's look at what the period is. Now on the coordinate plane, if I go from 0 to pi by 2, first at 0 radians sine 0 is 0, at pi by 2 sine pi by 2 is 1, at pi sine is again 0, and at 3 pi by 2 sine is minus 1. After that, if I again move pi by 2 radians and come back to this original angle, it will be 360 degrees or 2 pi radians, and I will be back at this position. Again the value of sine 2 pi will be 0. After that, if I keep moving like this, the values will keep repeating. So we see that after one revolution, the value of sine x is again repeating and repeating like that. So for sine x, the period is 2 pi. That means sine of 2 pi plus x is same as the value of sine x. Correct? So with this knowledge, let's look at the graph of sine x. So the benefit of having a period while graphing a function is that we can draw the graph of the function from 0 to the period, and then the function just keeps repeating again and again, right? So to make the graph of sine x, I am writing a few points on here on the x-axis. This is 0, then pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and so on. Say this is 3 pi. Here minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi, and so on. Okay, so now we know that the range of sine x is from minus 1 to 1. Alright, so let's come back to the coordinate plane, and this will help us graph the sine x function. So at 0 radians, the value of sine x is 0. At pi by 2 it is 1. So from 0 to pi by 2, value goes from 0 to 1. Then at pi the value is 0. So from pi by 2 to pi, the value goes from 1 to 0. So it is increasing here, then it is decreasing here. Correct? Then from pi to 3 pi by 2, value goes from 0 to minus 1, and after that the value from 3 pi by 2 to 2 pi goes from minus 1 to 0. So the graph is increasing here and decreasing in these two quadrants. If I use this information to draw the graph, it will be something like this: 0 to 1 from 0 to pi by 2. Between pi by 2 to pi, it goes from 0 to 1 to 0, then from 0 to minus 1, and then from minus 1 to 0 again. And this is all that we need to draw, okay, because we have covered the complete period. So now we can just simply repeat the graph. on both sides. And this will be the graph of y is equal to sine x. Okay, so let's go to the second function, y is equal to cos x. Again, we look at the period of this function. So value of cos x, at 0 radians it is 1, at pi by 2 it is 0, at pi it is minus 1, and at 3 pi by 2 it is again 0. After the complete revolution, we come back to the same point, and the value of cos 2 pi is again 1, value of cos 5 pi by 2 is 0, and the values keep on repeating like that. So period for cos x is also 2 pi, correct? Okay, now using this we can graph cos x Alright, so at 0, now the range of cos x is from minus 1 to 1. So at 0 radians, cos x is equal to 1. At pi by 2 it is 0. At pi it is minus 1. So from here to here, the function is a decreasing function. After pi, the value grows from minus 1 to 0 at 3 pi by 2. And from 0 to 1 at 2 pi. So now the function is an increasing function. So from 0 to pi it is a decreasing function. The value goes from 1 to 0 at pi by 2, then from 0 to minus 1 at pi, like this, and then it is an increasing function and it grows from minus 1 to 0 at 3 pi by 2, and then 0 to 1 at 2 pi. And since 2 pi is the period of the function, we can just repeat the graph on both sides. This gives us the graph of y is equal to cos x. So let's look at the third function, y is equal to tan x. Now again we look at the period of tan x. Tan x is 0 at 0 radians. It is not defined at pi by 2, so it tends towards infinity in the first quadrant. Then as soon as it comes to second quadrant, that means the angle is just bigger than pi by 2. As soon as the angle is just bigger than pi by 2, tan x will become negative, but its value will be still considerably very high. So the value will be minus infinity, okay, just after pi by 2. At pi it is again 0. Then in the third quadrant it will tend towards infinity, as it will be positive. Just after 3 pi by 2 it will be negative, so it will be tending towards minus infinity, and then it is going towards 0. So we see that it goes from 0 to pi, and then from 0 to pi infinity, and then from minus infinity to 0. After that it again repeats all the values. So in this case for tan, period is pi radians. So the graph of tan x, we see that the angle cannot be equal to pi by 2 ever. So x is equal to pi by 2 is an asymptote for the function. Same for 3 pi by 2. Minus pi by 2 is also an asymptote. Minus 3 pi by 2 is also an asymptote, and all these multiples, odd multiples of pi by 2 are asymptotes for the function. Now the value of tan x goes from 0 to infinity in the first quadrant. Just after pi by 2, the value changes from plus infinity to minus infinity, and from minus infinity it goes to 0 in the second quadrant. Now the period of tan x is pi only, so we need to make the graph only from 0 to pi and then repeat it on both sides. And this gives us the graph of y is equal to tan x.